we should be live. Exciting. All right. So welcome to Redis Labs. Welcome to the Silicon Valley Redis Meetup group. And this is our first talk of the year. And who knows what unusual day yesterday was? Palindrome is a palindrome. It was, let's see, 02022020, I think, or something like that, right? Oh, backwards, the other way. So that was kind of fun. So we're going to get going right away here. I just want to do a couple housekeeping. Of course, you got the Wi-Fi. Hopefully, you got some food, and we got some more food coming for those of you who are still hungry. And if you want to find out more about the talks that we've done or the recordings that we've had, you can go to redislabs.com/tech-talks, and you can find more of them there. A couple of things I also want to share is that we have RedisConf coming up in May. It's May 12th to 14th. The actual conference is the 13th to 14th, and we have a training day on the 12th. It's a full-day training day. And you can find out more about that at redisconf.com. And so we're going to go ahead and get started now. Before we go any further, again, I just want to do a quick show of hands. How many of you are using Python today? Lots of you. Okay, well, you're in a good place. And how many of you have used Redis? Okay, I hope to see all of you at RedisConf. And if not, I hope that you'll check out the videos and all that kind of stuff that we have online. So let's go ahead and get started. I should be able to swipe here. Nope.
3 fingers.
What's that?
3 fingers.
Oh, 3 fingers. There we go. Cool, it works. So we're going to go ahead and get right into the talk, learning how to build a client library in Python from scratch. I'd like to introduce all the way from Milan, Italy, our developer advocate in the Europe area, Loris Crow. Come on up, Loris. I'm going to give you the spot right here, and take it away.
Okay, hello everyone. Before we start, a couple of things right now. For me, well, okay, this is my social media stuff, what I do, just a weird photo of me. I don't know if you can see this, but for me, right now, I think this is the right window. Run text. Okay, so for me right now, it's 4:30 a.m. in the morning. I'm still on the European time zone. I'm kind of jet lagged. I've been drinking a lot of tea, but I'm not at 100%. That said, I think my computer science professor used to say that software engineers do their best work after 1 a.m. But we'll put that to a test right now. But I'm sure I'm going to make a lot of mistakes. So if you see anything terribly stupid that I'm doing and I don't notice after 1 or 2 tries, please raise your hand, scream, let me know. Second thing is I'm going to try to give an introduction where I kind of discover things as I do them, but in reality, I've already done this. I've rehearsed this presentation, and I wrote a kind of full-fledged serious Redis client in another language already. So, don't be surprised if some things to me sound more natural than they sound to you, because it's not new stuff for me. Just so you know, because occasionally presenters, they kind of look super clever, but they know the stuff already, right? So just so you know. Okay, so let's get started by, oh no, where's my terminal? Here. Oh no, this got too big, should be smaller. Let's start by setting up the terminal. Okay, clear. So, how many of you have used Redis CLI in the past? Just raise your hand, please. Okay, a bunch of people, not too many. So if you use Redis CLI, is the command line that allows you to interact with Redis, and you can send commands to it, like flush all, that deletes the database. I'm doing that right now, so I don't have all the keys that I set up earlier when I was rehearsing. But the basic commands are like set, hello world, and then I can get hello, and I get what I set the value earlier to. But here's the thing. When you're using Redis CLI, you're not seeing the protocol. You see a human-readable version of the replies from Redis. What the Redis CLI is doing is reading the protocol from the wire and then parsing the reply and then showing it to you in a nice way. So if you want to really see what's happening on a TCP connection level, you have to use something else. You have to use something like Netcat or telnet. I'm going to use telnet, and it's in the bottom terminal. And I'm going to connect to local host 6370. Oh yeah, sorry. Let me. Ooh. Okay. That work? Okay for everyone? So I'm not going to use the terminal for too long anyway. So now I opened a TCP connection. How many of you have programmed like a socket software where you read bytes from a TCP connection and write bytes to it? Raise your hand, please. Okay, a lot of people. So I think there are some interesting things to learn from this if you've never done in the past. Let's just start by sending the commands that I sent earlier. So if I set hello to world, it works, and I get an OK reply. It kind of looks like the OK reply that I saw from Redis CLI, right? But there's a plus in front of it. Let's see what happens if I try to get hello. Oops. Get hello. So if I get hello, I get something different. I get $5 and then world. So you can see that it's not that different, but there are some differences. Now, at this point, I guess it makes sense to kind of check out the documentation. And on redis.io, there's the Redis protocol specification with which a bunch of explanations. I'm going to just scroll straight to the part that I think is relevant for today, which is the explanation of how the protocol works, right? So for simple strings, you get a plus starting, and then you get the string itself, ending with a couple of, ending with a /r/n two characters, the CRs, LF, what is it, like return carriage, new line, and carriage return a new line, and errors are the same but with a minus, integers with a colon, bulk strings, they start with a $sign, but they tell you how long the string afterwards is long, how long the string afterwards is, right? Because, for example, for word, we received $1 first, then a 5, which are the 5 characters of the reply, and with new lines in the meantime, in between. So if you also scroll down the documentation, there are more explanations, and it shows you that these are the 2 characters that we weren't really seeing in the inside of telnet, or at least we were seeing the new line, but you don't see the /r, and there are both bytes that you need to read. This is a small detail, but it's important because when we are going to read from the TCP stream, we will need to read the right amount of bytes because you want to read everything that you need to, so that when the new reply comes in, you start from the right point. Otherwise, your client gets out of sync with what's on the wire. So these are basically the basics. Redis sends you a text protocol that you can read from telnet. It's not too complicated, and that's basically what you need to do with your TCP connection. So I want to write a modern client, so I'm gonna do a client that supports async await in Python. How many of you have used async.io in the past? Oh, not that many. Okay, so async.io basically allows you to do event and networking with Python 3. And if you, how many of you have used like Django in the past for like Python? Okay, a lot. So if you have a Django application on Python 2 and you run a process, that process will be able to only serve one request at a time. If you have like 4 or 5 connections, requests coming at the same time, they will have to be solved sequentially, because with blocking networking, every time you're doing some kind of I/O, you can only, your whole process will block. And as you know, multi-threading with Python is complicated, and that's just how it is. With async IO, what the process does is basically it will juggle multiple connections at the same time. It will juggle multiple execution paths, let's say. And whenever one of these execution paths has to block because because it's waiting on the wire for the other thing on the other side of the network to reply, it will then pause that thread of execution and start another one. I said thread, but they're not system threads. They're something else. Usually people refer to them as like green threads or something else. But here's the reason why you might want to use async IO, because basically it allows you with a single process to solve, I don't know, thousands of requests, I guess, from just a single process on a node. So it's pretty nice. So this is the API on the official Python documentation. You can see that it uses async IO open connection, and it gives it a host and a port, and you get back a reader and a writer. And from that, you can write to the writer, read from the reader, and it's basically as simple as that. One small detail is that writer has a write method that it's not asynchronous, because I guess it writes to a buffer, but then you have to drain the buffer, and that's an asynchronous operation that you have to await. So let me just first try in an interpreter this stuff, so we can play with it a little bit before we start coding. So here's an interesting thing. If you start a Python interpreter and you import async IO. Sorry, I have a timer set up. I want to see if it's running. Okay, so import async IO. If I try to do what the documentation says, so this get reader and a writer awaiting async IO open connection, if I try to do that, so this is gonna fail. Just let me show you. What did it do wrong? Yeah, exactly. Await outside of function. So you cannot try asynchronous stuff, async IO stuff on the Python interpreter. This is super annoying. One easy fix, easy for you that since you are the user, but not easy to write, is to use instead IPython. If you use IPython, you get a beefed up interpreter that can do async await, because basically behind the scenes the interpreter is going to rewrite the command that you send to it. It's going to wrap everything in an async function, coroutine basically, do a bunch of top secret stuff to make it work. You don't care about it. What you care is that you just want to run await stuff at the top level. So let me try again. Import async IO. Reader and writer are await async IO dot open connection localhost 6379, and it works. So let's try to send a command from here then. So the writer had the write method to write to it. This opens the second big problem with Python. So write set hello world. Remember that you need to end everything with a new line, because whenever we send a command from telnet, we would always send it with the enter. And by pressing the enter key, you add a return carriage and a new line at the end. So you need also to add those. Then here's the problem. Data argument must be a bytes-like object, not string. How many of you are familiar with the difference between strings and byte arrays in Python 3? Kind of one person, yeah. That's a super confusing, annoying change that was introduced in Python 3. Long story short, strings in Python 3 must be UTF-8 encoded. They're not just bytes. They need to be valid characters, printable, that follow the UTF-8 encoding. That's annoying in so many ways. I think I would need like 7 meetups just to explain why I hate this choice. But you can still produce like just normal byte things that can contain every character, and by just appending B in front of the string literal. If you think about this in Python 2, it was the opposite. Normal strings were byte arrays, and you would append a U for a Unicode string. But they flipped it around in Python 3, and this is what it is. So now you have to basically either use the B thing, or use, here you can see that the documentation is doing dot encode, and use dot decode to make binary arrays become uniform strings. It's annoying. You will see a bunch of encode decode here and there in the code that I will write, and it's just to fix this thing. It has no other meaning than to make the Python gods happy. Okay, now it worked. I need to call the other method drain, right? But that drain needs to be awaited, so await w.drain. And now I can read from the reader. So await r.read, and I'm gonna read, I don't know, 100 bytes just to get everything. So nice, we got a plus, okay, carriage return and new line. So it worked. We actually sent the command, we read it back, and everything works. Now, one small hidden problem, which is annoying somewhat, is that here I asked it to read 100 bytes, but I didn't get 100 bytes back. I got whatever bytes were in the stream when I sent the command. This means that, unfortunately, whenever you try to read from a stream, you cannot guarantee that the system will give you as many bytes as you requested. It will give you up to that point, which means that whenever we will be going to read from the stream, you will see it will need to be in a while loop, because I will need to get all the bytes that I can get, which might not be enough for my purposes. So, for example, if I want to read this reply, I need to read up to the new line, right? And every other reply will require me to read up to the new line so that I know what the length of the next piece is. So that also will require me to read up until the end. It will require me to read 5 bytes, right? But if I call read 5, I could get only 3 bytes, because maybe Redis hasn't sent me all the bytes yet. Like with these small pieces of text on a local process, it's never going to be a problem. But in reality, there is no concept that you can easily use at this abstraction level that tells you the other side has sent a full reply. There is no full reply. You know that a reply is full because the protocol somehow tells you how much bytes you need to read, because either you know that you have to read up to until a new line, or because you know the length of the next thing, or what the length of the next thing is. But yes, you're only reading bytes, and that's super annoying if you're never used to it. And we're going to have a bunch of while loops in the code. So I think we can get started now. Okay, I'm going to write this here. I have a bunch of tests that I wrote down because I want to do these things in order. And let's see. So we start by importing async IO, I guess. Then we want, let's set up the main function. In which we'll do stuff. And then we do the usual if main. I need to do this because from the main, I cannot just call an async function. I need to schedule the function on the main event loop when using async IO. So I need to do also async IO.run of main. And here the parentheses, they're not a mistake, because async functions are kind of like objects. So you need to instantiate them, and only by scheduling them, only by scheduling an instance of an async function of a coroutine, you can then have it run for real. So let's see if this works. OK. Oops. Hello, thank you. Works. OK, step 1 completed. Well, not the test, but like step 0, let's say. OK, now we need our client. And we need to do the connection thing that we did earlier in the interpreter, right? So we need a class. I'm going to call it Redis client. Now, at this point, what you might want to do is to write an initializer and have the initializer do the connection. But initializers cannot be asynchronous. So I'm not going to write any initializer, and I'm just immediately write an async method called connect. Self, and then host, and then port. And what I'm going to do is I'm going to just save inside the object the reader and writer thing from before. Oops. OK. So open connection, host port. That should be fine. And that means that usage is basically client equals Redis client. And then await client.connect localhost and port 6379. OK. Let's see if this works. And one way to see if what we're going to do is working. Here, I'm launching the Redis server instance. And I'm setting the log level to verbose. So it's going to basically spam log lines over the state of the database. And it's also going to inform me whenever a client connects and disconnects. So if what we did works, we're going to see a corresponding log line there. So I don't get any error here. Let's see on the other side. Yes, we do. We see that a client was accepted and then closed the connection. So that's us. That's fine. So starting point reached. Next, we need to be able to do set a key to something. So let's write that. So, sorry. Yeah. Async def set self key value. So to do set, we need to write the command and then read a full reply. So let's start with that. Self.w.write. So I'm going to use these format strings, and then I'm going to encode it as a byte string. Inside of that, I run set, and then key, and then value. And then the new line in the end. Then after that, I need to drain, if you remember, but I need to await the drain. W.drain. And then I need to read the full reply. So as a starting point, I'm just going to read whatever. I'm going to read like 100 bytes just to see whatever comes back, and then maybe I'm going to verify that afterwards. So I will return and await self.reader.read 100 bytes. Don't decode, so I see one less byte thing from Redis, from Python. OK, let's make this work. So print, because I want to see the result of what I'm doing, of await client.set banana hello. OK, that sounds fine. Let's see if it works. Error. What did I do? Coroutine object has no attribute the code. because I need to, oh my god, I need to wrap it within the await, because the code was applied to the coroutine. Before the await, I need to set up operator precedence correctly. Let's see if it works. It works. I get hello thank you, well, from before, and now I get the plus OK plus the new line. So that's good. Next, we need to decode the reply properly, right? We need to get just the OK without the new line, without the plus. So let's set this up. So I'm going to create another async method. Since it's a private method, because it's not something that should be used directly by other people, by the other programmers outside of the class, I'm going to start with an underscore, call it read reply self, and that's it. I don't need any other parameter. So I need, if you remember from the documentation, I need to start with the tag, and depending on the tag, then I'll know what the reply is. So in that case, I just want to decode the plus OK for now, so I'm just going to implement this case. So I need to read the tag self.r.read 1 byte, and then I'm going to switch over it. Of course, Python doesn't have switches, so I'm just going to do a bunch of if-else things. So if tag equals, remember that I'm reading bytes, so everything has to be prefixed with a B, equals plus. Then for pluses, these are simple strings, and you know you have to read up until the new line. So I'm going to store the result here. So I'll start with a simple empty string. Oops. Then this is my small single character accumulator. So my character starts also as an empty binary string, and then while my character is different from a binary new line, which is the same as a Unicode new line, but you have to be explicit about this stuff, I'm going to read a new character. And I'm going to append it. Actually, I could, yeah. I'm going to append it. Result plus equals the character. So after I'm done reading up to the new line, I need to return the response. So return the result. But if you remember, there's also a carriage return before the new line. So I'm going to exclude the last character, and I'm going to decode everything so that I get a normal string, not a B prefix string. I'm also going to add immediately an else branch, so that whenever I get something weird, I'm gonna something that I don't recognize, I'm gonna display this as an error instead of like returning nothing or doing something that is not doesn't give you any information. So what I'm gonna do is that if I don't recognize the tag, I'm gonna just read 100 bytes as context to see what the rest of the message is. And then I'm going to raise an exception. Okay, I probably also need to decode the message. Also the tag 2, actually. Oh, whatever. Let's see if it works without. If I get an error, I'm going to add all the dot decode, whatever, everywhere. So I have also the error path written. Oh, before I forget, I need to wire this up in my set method. So now I'm not going to just read 100 bytes randomly anymore. I'm going to do a proper self dot underscore read reply. Okay, and I need to await that. Oh, by the way, just to show you what happens if you make a mistake. If you don't await stuff, you get a runtime warning that tells you coroutine, whatever, was never awaited. This is a good indicator that you forgot an await somewhere. Just so you know, I got a lot of those while rehearsing because I would always forget to await stuff. Nice. I got my OK, just as it should be. Let's try another command now. So what's the next? Get banana. So we can set banana to hello, mission completed. And now let's try to get the same key. So the get is going to be another method. Self key. It's the same idea as before, but this now is going to be just get, and there is no value. It's just the key.
Is it still the right?
Sorry?
Is it still going to be the right? Because get is going to just read, right?
To repeat.
Sorry, just
Get is a command you have to write.
Oh, okay.
sorry, I didn't catch.
So self.write, because self.write is going to write it, right? So write get.
Yes.
So I thought we were just reading it.
I am reading, but I'm reading from Redis, but I need to write the command to the stream first.
Okay.
So this read and write, this write and this read, they are about me writing and reading from and to the TCP stream. While this set and this get, they are writing and reading from Redis. So these are two different abstraction levels. OK, so I also need to do the drain again, of course. And then I can just read the reply. So it's basically the same, it's just a slightly different command. OK, let's see if I can do it. Oops. I'm going to copy the line, and this time I'm going to get my banana. Let's see if it works. I get an exception, but it's my exception. Unknown tag, $, and that's what's after $. So we know that we encountered a new case that is not yet covered by our parser. So I guess we need to add the new case. So if tag, this is a bit more annoying than the previous one. So if tag is a binary $, then we need to do, so if you remember from here, we need to first get the length after the $, and once we know the length, we know how much we can read afterwards. The reason why these are length prefixed is because this allows you to have new lines in your string, in your value. Because with the simple strings, the new line is your end character, right? This is where you expect to end the message. But so that means you cannot have new lines in between. And simple strings are only used by Redis internally to give you OK or very simple responses. Like whenever you get a key value from Redis, it's always going to use bulk strings that are length prefixed. So because you can have new lines in your stuff, and you shouldn't break the protocol, of course. Let's do this other case. So I need to find the length. And as a starting point, length is an empty string. Then, as usual, I have my character that I used to read stuff from the wire. So while my character is different from a binary new line, I'll read a new character. One at a time, and I'm going to add it to the length. Now, so after I'm done with this, I'll have all the single characters that compose the length, the numeric length, but I need to go from a string to a number, to an actual integer. I'm gonna do this and kind of abuse of the duck typing in Python. So I have the duck typing T-shirt, so I think I'm allowed to do that. I don't recommend you do this in your own code for real. That's terrible practice. If a colleague did any of this in the code base, I would hate him or her. So just so you know. but it's fine for now. But actually, there's one small detail. Again, we are stopping on the new line, but we need to get rid of the return carriage. I think Python might do that for us, but just to be clear, we only want to give it like the actual digits. So now we know how much we have to read. So the result, again, starts as an empty binary string. And we do read, but this time we don't read character by character because how much we want to get to. We just need to understand that we might get all that many bytes in chunks. So what I'm going to do is I'm going to do while the length of result is less than my expected total length. Maybe I should call this total length. You know what? Yeah, let's call it total length. So while I'm not done, I'll need to append to result a new chunk. This chunk is going to be how much I want in total minus how much I already got. So I start by asking for everything. As I get something, I ask for less and less until I'm done. After that, so with this, I will read all the 5 characters, but there's also a return and a new line in the end. So I need to read 2 more bytes. So in this case, what I'm going to do is that I'm going to add 2 to my total count of bytes that I want. And then when I return the result without the extra characters that I don't need, so the new line and the return carriage. And I'm also going to decode the reply so that I get a nice looking string. Let's see if it works. OK, worked the first time. Nice. One step closer. Now, third test, increment banana. Let's try to increment banana. Kind of the same thing as before, just a different command. This time is incr. Let me show you in Redis CLI how incr works. So it basically increments a key that contains a numeric value, right? The problem is our banana key right now contains a string, doesn't contain a number. So this is going to return an error. Let's see what happens. So I implemented incr correctly. Yes. Am I calling incr down here? I am. So let's see what happens. OK. That's unexpected. Did I save? I did not save. Right. That's what I expected. So I got an unknown tag minus, and then followed by error. This value is not an integer or out of range. So I did get an error from Redis, which is what I expected, but I'm not implementing the errors case. And simple errors are basically the same as simple strings. So what I'm going to do is I'm going to copy paste whatever is in the plus case and do it also in the minus case, right? But the difference is that in the minus case, instead of returning the value, I'm going to actually throw it. Let's see if it works. Nice. Still an exception, but in this case, it's a different type of exception. I could also, like if I wanted to, I could like have a, instead of a generic expression, I could call it like a Redis error reply or whatever. So it looks like an exception, but you know it's a different type of exception than the other one. OK, so we're done also this, but let's try to incr banana correctly this time. So let's set banana instead of hello, let's set it to a number, let's set it to 1, and let's have it do the increment correctly. Now we get another different type of reply. We get a colon and a 2, right? So that's what you would expect. but we didn't implement the colon case, which is a number. So again, I'm gonna kind of copy paste whatever I did for the minus case, but I'm gonna do it for the colon. And in this case, it's not an exception, but it's an integer. So I'm gonna return it as a Python number. Okay, exceptions must derive from base exception. What did I do? Oh, right, should not be raising it, I should be returning. Cool. Now I have also increment. I have 1, 2 test cases. So let's try to set banana to hello world. Actually, what I want to do is basically set banana to this string and this banana to this string. So let's try to do this. And let's see what, actually, I'm also going to comment everything else so that we can focus on, I'm going to leave the hello async, but so that we can focus on just the new test case. Okay, I got a error from Redis that says syntax error. And the reason why I'm getting syntax error is because, actually, let me show you one trick. So if you run Redis CLI and you call monitor, with monitor, you can inspect every command that gets sent to Redis. So if I down here exit from telnet and I run my script again, up here you can see that I sent set banana hello world. But these two words right now are interpreted by Redis as 2 different arguments, but they should be a single argument. So I'm missing some quotes around them. One way of, I guess, kinda temporarily fixing it would be to do this inside the code. And that's gonna work for this case. Now I get an OK, everything works, and here I get the proper syntax. But it's not really a real solution because it breaks immediately. Like if you look at the last test case, so set banana hello new line world, look what happens. I get a protocol error. I don't even get a line inside the monitor because I'm not like the error is not at the syntax level, meaning I gave to Redis a syntax, a command with a wrong number of arguments, since set expects 2 arguments. But I had a protocol error, so there's something wrong at a lower level. And basically the problem is that commands sent in the way I sent them cannot contain new lines. The actual truth all along is that the protocol that we were using to send commands is human readable, is super easy, but it's not the real protocol the client should communicate with Redis normally. Let me go back to the documentation. No, not here, here. So if you scroll down after all the examples, you can read clients send commands to the Redis server using RESP arrays. And we weren't doing that. And RESP arrays basically look like this. They tell you how many items are in the array. So star, how many items in the array. And then this is the first item, a string long 3 characters. And here's the second number, another string long 3 characters. So that's foo and that's bar. And that's how we should communicate with Redis. The reason why Redis doesn't complain if you send it like, let's call them plain text commands, is because it's easier for developers to get started doing so. So in reality, there's a secret protocol, a secret RESP sub-protocol that is basically just the plain text sending commands, which is useful to get started, but it's not complete. It doesn't support everything. So what we need, basically, is to do a little bit more work and actually write our commands in the right way. So what I'm going to do is that I'm going to implement one last method, a generic method that allows me to send any type of command, but then I'll have also to explicitly specify which command I want to send as an argument. And I'm going to do it with the right protocol syntax. So let's see. Async def. I'm going to call this method send self. And then I'm going to accept a variable number of arguments, because some commands take one argument, or they're 0, or they're even variadic, so they can accept a variable number of arguments. So I need to write in the protocol a string that starts with how many items are in the array, how many arguments I have. So what I'm going to do, I'm going to start with this self.writer.write. I'm going to do it with a format string. So I need to start with the star, because that's what indicates a array type. And then I need to continue with the number of arguments as a string. So len of args. Then there's a carriage return. There's a new line. And then there's the arguments themselves. So RESP. But they also need to be encoded as a RESP string, right? So we need also to do that. And I also, before I forget, I also need to encode the then string code. So, no, that's not what I wanted to do. OK, so how do I procure RESP args? I'm going to use a list comprehension. I hope nobody finds them too confusing. I mean, after a while that you do Python, you kind of love them maybe a bit too much. There was a point in time where I would do everything as a list comprehension of a list comprehension of a list comprehension sometimes. Anyway, so each argument needs to become a string that starts with a $sign that tells you how long the string argument is. So I'm going to do len of x. Since this comprehension is like for x in args. And after that, there is a carriage return, a new line, and then there's the thing itself, the carriage return, and a new line. So this is going to compose the RESP protocol for each element and produce a string of those, and then this wraps everything in the array prefix, let's say, length prefix. What am I missing here? So I'm missing two things, no, only one. I need this to become a string, because right now it's an array, so I need to join it to become a single string. OK, this is the most convoluted part of our program right now. I'm going to drain the buffer, so self.w.drain. And then, as usual, I'm going to read a reply. So let's see if our send command works. Looks fine. Am I missing anything? So one interesting thing is that arrays don't end with a new line, a carriage return and a new line. They tell you how many items there are there, but there is no tail, let's say. This is a small detail, but it's genius. When I was writing a parser in another language, yes. When I was writing a parser in another language, I noticed how nice it is that arrays don't have a final carriage return and new line. It's too long to explain in this context, but if you want to know, come find me after. I'll be able to explain. Yeah. OK, so let's try this out. Wait, I need first to call the function. So instead of set, I'm going to call send. But now I have to specify which command I want to send. So I'm going to send banana with all the new stuff. Let's see if it works. Whoa. I don't know why. Why is this here? Come on. OK. So, OK, I got OK. Let's see if Redis CLI. Let's see if the key was actually set correctly. Get banana. It does contain hello new line world. Nice. Let's try to call something else. Hset banana field 1 value 1 field 2 value 2, whatever. The quotes are not the same, but who cares? I need first to delete banana because it's the wrong type right now. Let's run it, and I get 2. 2 is the number of fields that I set in the hash map. Each set sets fields inside a key that contains multiple field value pairs, so a dictionary in Python, using the Python nomenclature. I cannot get banana anymore because it's not a string anymore. So I have to use the right getter for this type, which is hgetAll. Well, one of the different getters. Banana. And I get field 1, value 1, field 2, value 2. So it works. I did everything right. Now with this last command, we can send, with this last method, we can send any command, and everything works. And I haven't even taken a full 45 minutes to do that. So what else can I show you? I want to show you one last thing. So I covered most of the things that you need to have as a basic client, but Redis has transactions, pub/sub, a few other things that you might want to support in a real client, but there is also one other important detail with async await. I told you that if you use async await, a single Python process is juggling multiple threads of execution, and right now we were only sending one command at a time, or whenever we were sending, even when we were sending multiple commands, so if I uncomment these parts, I'm awaiting every command. So before I execute the next line, I need the first line to be completed completely, right? So this is actually sequential. So let me show you what happens if you try to do stuff in parallel with the current client that I wrote right now. I'm going to start by writing a test function, a test coroutine, that basically keeps incrementing the same key over and over. And I'm going to show you what happens if I call a bunch of those at the same time without waiting for one to be completed before launching the second one. So async def, I don't know, I'm going to call it runner or whatever, takes a client as input, and inside it does for whatever in range 1,000. Oops. 1,000, and all it does is await client.send inc banana. Now, instead of launching the normal commands, what I'm going to do, well, actually, let me just comment them. What I'm going to do is that I'm going to schedule multiple of those runners for execution. And you do that with asyncio dot, I think it's create task. Dot create task, runner. Okay, so what create task does is it doesn't block. It goes to the next line even if runner has not completed. And it will jump, if there are other await commands afterwards, it will jump back and forth between all different threads of execution without order, depending on whenever the socket becomes readable again. So let me see what's in. I need to delete banana, so that now it's not a hash map anymore, because if it was a hash map, all commands would fail. But in any case, it doesn't even matter if the commands fail or not, because here what happens? Oh, right. Important detail. No. Okay. Let's see. Here's what I get. Runtime error, read called while another coroutine is already waiting for incoming data. But this is a nice error, but I think before that we should get another one. Let me see. Finished coroutine, runtime error. Okay, let me try again, because it's not non-deterministic. It depends on, like, the error messages change depending on whatever happens. I'm still getting the same error. Let's try one last time. Okay, no, I keep getting this error, which is fine because Python is warning me that that the coroutines are walking over each other. But I tried this previously, and what I got was that I got an exception from my code from my here from my switch thing, where I would get an unknown tag and I would get a random byte that wasn't a tag. Because what happened was that the writes would happen out of order. So one coroutine would start reading a little bit, and then the other one would take over and read another little bit, and everything gets a little piece of everything, and nothing makes sense anymore. So to write a proper asynchronous client that uses async.io, you need to have a locking mechanism that allows multiple threads of execution not to walk over each other. So you need to have like some kind of queue. There has to be some kind of ordering, which is a small detail that people don't think about, but it's like something that has also a performance implication when you compare asynchronous code with blocking code. Blocking code has a bunch of downsides. One is you cannot do too many things with the same process. Another one is you're wasting cycles or whatever. But asynchronous stuff comes at a fairly heavy price. And yeah, that was also an interesting discovery that I made while writing the other clients. So I think I showed you everything that I had to show you. I'm going to put online this code, of course, for everybody to see. I'm going to tweet everything and yeah, put the code on GitHub. So thank you very much for listening. I guess that was all for me.
Does anyone have any questions they want to ask us?
Nobody?
Couple questions?
How this client is different from the real package that Redis has already?
Okay, so the question was how this client differs from a real client. Real clients have, as a starting point, I would say, they're more than 100 lines of code. They, as I said, we would need to implement a proper locking mechanism that allows multiple coroutines to coordinate when reading from the stream, because right now, if you try to do multiple tasks at the same time, everything breaks. So that's one big difference. But other than that, a basic client, that's what it is. It's nothing much more than this. The other extra features that you're not seeing here are pub/sub and cluster support, for example, Sentinel support, a bunch of like connection options that allow you to connect to IPv6, Unix sockets, a bunch of things like that. Okay, my timer is going off. There's actually another thing that I forgot to tell you about, which is this. Let me show you something interesting on the top terminal. I'm going to open telnet here. Look what happens if I do hello 3. If I call hello 3, I'm going to switch to the new version of the RESP protocol, which has a few new types. Like if I do hget, let's say I do hset banana field 1, value 1, field 2, value 2. I need to delete it first, right? Hget all banana. Look, now I get a new type, a percentage type. This type tells me that the reply is a hash map type, is a key value pair types. This is a type that we didn't encounter before, and it's only present in RESP3. And there's a few new types in RESP3 that makes RESP3 a bit more powerful. So this is another thing that new clients support. So the switch case, instead of having like all the few cases that we did, and there were still some missing, right? Because array replies were we weren't able to parse them. I didn't do any list command, but if you were doing list commands, you would get list replies, and you would need to parse those. But it's easy. But there's also with RESP3, there's hash maps, sets, booleans, because right now booleans are 1 and 0s in RESP2, but in RESP3 they are actually a different type, so you can get an actual true and false in your language more easily. So yeah, that's pretty much it. A new protocol, a proper queue locking system, and support for pub/sub and cluster and Sentinel. That's pretty much the big difference. Everything else, it's just what you saw. Any other question?
Well, it's more a remark, but I think there is a module called Hiredis, Hiredis, which is a Python module that wraps a C library that helps with like decoding messages.
Oh yeah.
That part is kind of already available if you guys want to write your own client. You can.
That's a good point. I'm going to repeat it for the stream. Of course, yes, you don't have to write everything yourself in Python, even though it's educational, right? I think it's kind of fun, but that's why I wanted to do this presentation. But like in real life, you can import from Python and basically every language that has C ABI compatibility, so that can import C binaries, and you can import Redis, which is it's the C client written by Antirez himself, and you can use the parser to do parsing in C, which is just a little bit more faster than in Python. It's like a few orders of magnitude, but that's how it goes. So that's another resource. Yes, absolutely. And Redis Pi itself, I think, makes use of it. So if you install Redis, you will also have a more efficient Redis Pi. Anything else? I guess not. So Dave, do you want to take over?
Oh, yeah. Okay. So, by the way, I want to comment that I'm sitting up here in the front row, and I'm noticing somebody coding right along with you. And it was kind of fun because I could see that every time she hit enter and it worked, she'd go, yes. So that was pretty cool. Anyway, all right, so no more questions. All right, just a reminder, just to make sure for those who are new, yeah, you don't have to create your own client library in order to use Redis. This is really a learning exercise to learn how to code and learn Redis at the same time, I guess. But you can go to redis.io /clients, and you'll see a bunch of client libraries there in all programming languages.
But they all started kind of this way, right? So
yeah.
If anybody wants to contribute, that's a decent start.
Yeah, in fact, the most popular client library for Ruby was started within hours after Salvatore's a link to Salvatore's first Redis repo was published on Hacker News, and a guy named Ezra, who was the co-founder of Engine Yard, basically did something like this and just put something together to call the API, and he liked it so much he published it up on Twitter and got a whole bunch of Ruby on Rails developers using it, and that's how these things get started. So if you're interested in that story, you can go to redislabs.com/blog, and I think the blog post is called Redis Turns 10, and we talk about that, how that got started, how Redis started in the Ruby community. So I think that's it for more talks like this. In fact, I'm sure Loris has some up there. You can go to redislabs.com/tech-talks, and you'll find more videos up there. And that's it for this meetup. And we hope we'll see you at RedisConf in May or back here for our next meetup. Thank you very much.